Hi, this is Archana. Today I am going to explain the protective relays. In previous video lecture, I discussed about the circuit breakers. The circuit breaker is an electromagnetic device to protect an electrical circuit from overcurrents. When the protective relay giving the indication to it, the relay is an sensing device. It senses the fault and it gives the indication to the circuit breaker. Then the circuit breaker is operated. Now in present video lecture, I explaining what are the objectives of power system protection and introduction to the protective relay, functional characteristics of protective relay, working of protective relays, basic connection diagram of protective relays and types of electromagnetic relays. Okay, first coming to the objectives of a power systems. The various power system protective components are fuses, circuit breakers, relays, lightning arresters, etc. are the main protective components in the power system. The main objective of power system protection is to protect the various equipments in power systems from abnormal or faulty conditions. Okay, these are the various protective devices in the system. That is, the first one is the circuit breaker. This is the circuit breaker, and second one is the protective relay. In previous video lecture, I am discussing about the overall circuit breakers. In present video lecture, I am discussing about the protective relays. These two are the main protective devices in the power system. Okay, the main objective of power system is to keep the power system stable by isolating only the components that are under fault. If any faults are obtained in the power system, only that particular part may be isolated and other part will be within the safe zone or within the stable condition. Okay, these are the various components in the protective device, power system protection, that is the generators, transformers, bus bars, transmission lines. This is the single line diagram of a power system protective equipments. First one is this is the generator protection. The main component in the power system is the generator. That's why we compulsory give the various protective devices for controlling the faults for generators. Okay, this is the generator protection. In that we are connecting the one circuit breaker that is connected to the relay. RG is the relay, generator relay. Okay, next one is the transformer protection. The generator and transformer is the one of the major parts or major equipments. It is the costly equipments in the power system. That's why we giving the separate protection for generator and transformers. This is the transformer protection. In that this is the T1 is the transformer and C2, C3 are the protective devices for this transformer. That C1 and C2 are connected to the relay. Okay, when the fault will be obtained, the relay gives the indication to these two circuit breakers, then the transformer may be protected. Next one is the line protection. This is the transmission line protection. In that transmission line, we are connecting the one circuit breaker that is called the C4 circuit breaker. That C4 circuit breaker is connected to the RT4. RT4, that means the relay 4. Relay 4, that is connected to the bus bar. That is this is the bus bar protection. This is the bus bar protection. Okay, this overall are the bus bar protections. This is the bus bar. In that we are connecting the circuit breakers. This is the circuit breakers, this is the another circuit breakers, and this is the another circuit breaker. Each circuit breaker are connecting to the relays RL5, RB, RL6, RL8, others are the relay coils are connected to the circuit breakers. When the any fault will be obtained, that relay coil sensing that fault and gives indication these circuit breakers, and then the bus bar may be within the protective zone. Okay, these are the various equipments in the power system. Mainly the 4 types of equipments are there in the power system, that is the generator, transformers, bus bars and the transmission lines. We compulsory give the separate protection for each and every equipment that is given by the circuit breakers. Okay. Next one is the introduction to the protective relay. Introduction to the protective relay. It is a sensing device which senses the fault and giving a tripping signal to the circuit breaker. When the fault will be obtained, in that case the relay coil senses that fault and identify that fault and giving a tripping signal to the circuit breaker. Okay, it is the electromagnetic device. The relay is the electromagnetic device, is operating on moving parts to provide detection of abnormal conditions. Okay, this is the electromagnetic device. It is operating on moving parts. While operating that moving parts, the relay will be operated. Okay, this is the diagram for the protective relay. This is the protective relay, single line diagram of a protective relay. This is the protective relay, and these are the inputs and these are the outputs. Okay, this is the setting time. This is the setting time. We are giving the setting time to the protective relay, and this is the input to the protective relay. The input is given to the current and voltage transformers. Okay, current, voltage and transformers and temperatures, and output is the indicating by the warming alarm signal to the circuit breaker. Okay, these are the single line diagram of a protective relays. That will be when a fault current will be flowing through the relay coil, then the relay senses that fault current and then it gives the alarm signal, like this. Okay, this is the setting time. This is the setting time. While giving the setting time to the relay coil, then it will be observed for that setting time, and then it gives the warning alarm to the circuit breaker. Okay, next one is the functional characteristics of a protective relay or good features for the protective relay. What are the features for the good protective relay? Mainly we are having the 6 types of the features are there in good protective relay. That is the first one is the reliability. Next one is the selectivity, next one is the speed, sensitivity, simplicity, next one is the economy. Okay, first is the reliability. It means to operate an predetermined condition. Okay, next one is the sensitivity. Correctly select the faulted portion without disturbing the healthy portion. We select the particular faulty portion and without any disturbance to the healthy portion. That means the selectivity. Next one is the speed. The relay disconnect the faulty portion as quick as possible. Speed means that the relay disconnect the faulty portion as quick as the possible. Next one is the sensitivity. The relay must be operated very sensitive. Next one is the simplicity. The relay system should be so simple it can be easily maintained and it can be easily operated. Next, last one is the economy. Economy means that we consider the cost also. That will be deflecting for the per unit cost, then we consider the economy also. This is the various characteristics for when a fault will be obtained. This is the power transmission during various faults on the system as a function of the relay plus breaker time. This is the operating time, and x-axis we are taking the operating time and y-axis we are taking the power transmission. In that we are obtaining the various faults are obtained in the line, that is the line to ground fault, line to line fault, double line to ground fault and three-phase faults. This is the overall characteristics of the power transmission. Next one is the working of a protective relay. This is the simple working diagram of a protective relay, and this is the various components in the protective relay circuit. That is the, this is the control coil that is connected to the earth portion, and it is connected to the power source or tripping circuit. This circuit will be given connecting to the contacts of the circuit breaker. This is the contacts of a circuit breaker, and it is given to the load. This is the simple diagram for the protective relay circuit or protective relay connection diagram. This is the coil. This coil is energetic when short circuit current will be flowing through the relay coil that is connected to the current transformer. The input of this coil is given to the current transformer. When the overcurrents are flowing, that then automatically the relay coil may be energetic. If the relay coil is energetic or more MMF will be produced in that relay coil, then it closes the source circuit. Then automatically it gives tripping circuit may be closed, and then the contacts of the circuit breaker may be opened. Then the faulted line will be disconnected from the circuit. This is the simple working of a protective relay. Simple working of a protective relay. When the short circuit occurs, the current flowing in the line increases to an enormous value. If any short circuit currents are obtained in the transmission line or in the generator or in the transformer, then the enormous values of current will be obtained in that line or in the relay coil. This result, heavy current flows through the relay coil. Therefore, the heavy currents are flowing through the relay coil, causing the relay to operate by closing its contacts. Therefore, the relay operate and closing the contacts. Then the relay coil is energetic and closes the control circuit. Then the relay coil is energetic and closing the tripping circuit or the control circuit, and relay gives the alarm signal to the circuit breaker. While closing the tripping circuit, automatically the relay gives the alarm to the circuit breaker. Then the circuit breaker open and isolated the faulty section from the rest of the system. This is the overall simple working of a protective relay. This is the practical view of a protective relay. In that we are using the control circuit or the coil. This is the coil. When the fault current will be flowing through this coil, that coil will be energetic. Therefore, it closes the tripping circuit and it moves the armature and switching contact point, and this is the switching contact point. This is the iron core. If the relay coil is energetic, then automatically it moves the armature. Then the movable armature will be rotated and gives the indication to the circuit breaker. Okay. Next one is the basic connection diagram of a protective relay. This is the basic diagram, connection diagram for the protective relay. In that we are having the three parts. The total circuit will be divided into three parts. That is, the first one is the primary winding of the CT. This is the CT. CT means the current transformer, and this is the circuit breaker, and this is the bus bar. That bus bar is given to the circuit breaker. In that we are using the one CT, and that CT is secondary will be connecting to the relay coil. Then it will be connected to the 1 arm that is connected to the tripping coil, and tripping coil is connected to the battery. This is the construction diagram of a basic protective relay. Next, coming to the primary winding of the CT, that is connected in series with the line to the protection. Primary winding is connected in series with the line, and secondary winding of the CT and relay operating coil. The secondary winding of the CT is connected to the relay operating coil. Third one is the tripping circuit consisting of a source of supply and trip coil really stationary contacts. Third one is the tripping circuit is connected to the relay coil. Okay, next coming to the working, when short circuit occurs, if any fault currents will be flowing through the line, as fault on the line, the current in the line increases to a large value. This is the fault. F is the, in that circuit, F is the fault. Okay, when the fault current will be flowing through the line, the current in the line increases to a large value. This results in a heavy currents in the relay coil. Therefore, heavy currents will be flowing through the relay coil to the secondary of the CT. Okay, causes relay to operate. This is the heavy currents will be flowing through the secondary of CTs to this relay coil. Then the MMF will be released in this relay coil. Due to that MMF, this contact may be closed. When this contact will be closed, automatically the tripping coil is also energetic by giving the battery to this tripping coil. If the tripping coil is energetic, then the contacts of the circuit breakers are separated, and it gives the alarm signal, then the contacts of the circuit breaker may be operated. This is the basic diagram. This is the basic connection diagram of a protective relay. Okay, next types of electromagnetic relays. Okay, electromagnetic relays are classified into two types. Basically, these electromagnetic relays are classified into two types. That is the one is the electromagnetic attraction relay. One is the electromagnetic attraction relay. Second one is the electromagnetic induction relay. Okay, first one is the electromagnetic attraction relay. Okay, it is suitable for both AC and DC quantities. Attraction type of relay is suitable for both AC and DC currents. Okay, this relay operates on armature being attracted to the poles. Okay, electromagnetic attraction relay means in that name we are also having the attraction. Based upon the attraction, the relay may be operated. This relay operates on armature being attracted to the poles of an electromagnet. Based upon the attraction principle, the relay may be operated. Okay, the important types of electromagnetic attraction types are, the electromagnetic attraction types of relays are divided into three types. First one is the attracted armature type. Next, second one is the solenoid type. Next one is the balanced beam type. These are the basic important three types of a attraction type of electromagnetic relay. Basically, the attracted electromagnetic relay are classified into three types. That is the attracted armature type, solenoid type. Next one is the balanced beam type. Okay, based upon the attraction principle, the electromagnetic attraction relays are operated, and also it is suitable for both AC and DC quantities. Okay, next coming to the electromagnetic induction type of relays. In that name also we are having the induction. That means that relay will be operated on the basis of a induction principle. On the basis of a induction principle. Okay, it is also suitable for only AC quantities. It is suitable for the AC quantities. The induction type of relays are mostly suitable for the AC quantities. Next one is the principle is based on the split phase induction motor. The working of a split phase induction motor is same as that of a electromagnetic induction type of relay. On that same principle, the induction type of relay is operated. Okay, commonly or basically the electromagnetic induction type of relays are divided into 3 types. Okay, that is the first one is the shaded pole structure type. Next one is the watt-hour meter or double winding structure type. Next one is the induction cup structure type. These are the basic 3 types of a electromagnetic induction type of relays. Basically, the electromagnetic relays are classified into 2 types. Okay, that is the first one is the attraction type of relay. Next one is the induction type of relay. Attraction type of relay is applicable for both AC and DC quantities, and induction type of relay is majorly applicable for the AC quantities. The electromagnetic attraction type of relay is operated on the principle of the attraction. On the principle of the attraction, that means the armature to be attracted to the poles. Then the relay will be operated. Basically, the attraction type of relays are classified into 3 types: attracted armature type of relay, solenoid type of relay, balanced beam type of relay. Next one is the electromagnetic induction relays. These are suitable for the AC quantities. The working is same as that of a split phase induction motor. Okay, it is also divided into 3 types, that is the shaded pole structure, watt-hour meter or double winding structure. Next one is the induction cup structure. These are the basic 3 types of a induction relay. Okay, this is the various types in the electromagnetic relays. Okay, thank you.